Hello, my friends. Welcome back. We are looking to enhance the card game war project from the WiByte Python curriculum available at www.wibyte.in. In this video, we'll look at yet another interesting variant of the war game where, which is called Speed War. Now, the idea in Speed War is that we will keep eliminating the smaller cards. Now, this is interesting because presumably this will make the game more prone to wars, and that makes it more exciting. The way it will work is that we'll keep track of the lowest card that's still in play. To start with, it is 2, assuming we are playing with numbers and not suits. So let's go back to the original rules and say, well, the bigger number is the winner. Now, once the cards are put on table, just before they are added back to the pile of cards, either the player or the computer, we will remove any 2s that are there. So over time, basically 2s will be removed. Next, 3s will be removed. Next, 4s will be removed, and so on. So you can imagine that the number of cards is getting smaller and smaller as the game goes, and hence the game will become more and more competitive. Hopefully there'll be more wars. So that's the idea behind this variant. It was quite interesting to program. That's why I chose to sort of demonstrate this here. Now, to implement this speed war, I'm going to define a variable called smallest card, which will be set to card 0, which is basically to start with 2. And I'm going to use a new list called discard pile. Now this will this pile will contain all the discarded cards which are no longer in the game. I define a function called cleanup, and really what I'm doing in this function is that I'm going through every card that is on the table cards. If I find that the table cards matches the smallest card, notice I look at C1 because card here is a 2 string as always, color and suit and the number. Here I'm looking at the number, so I say, well, look, if the number matches the smallest card, I'm going to remove this from the table card. I'm going to instead append this to the discard pile. Now the point is I remove this before they are put back into the game, which means that once these cards have been removed, they are actually taken out from the game. Where do I call this function? Well, I call this function just before the player or the computer in fact picks up these cards, and that happens either the player wins or the computer wins. It never happens in the war situation. Either of the two wins. Basically, if let's say the player wins, in the regular game I just say player cards extend table cards. Basically I take all the table cards, put it in player cards. Here I'm saying I'll clean up the smallest card first and then I'll place this. Now that's the same in the computer win situation. Finally, remember, my smallest card must keep moving up because 2 must become 3, 3 must become 4, 4 must become 5, and so on and so forth. I do that with this piece of code. It may look a little bit confusing. We'll talk about this in just a moment again. The idea is very simple. There are 4 of every card. So there are 4 2s, 4 3s, 4 4s, and so on and so forth. So I just figure out if my discard pile length becomes a multiple of 4, then I know it's time for me to move to the next card. That's what this code is doing. Basically, I say, well, look, if my length pile, if my discard pile becomes, let's say, a multiple of 4, to start with a 0, it becomes 4 at some point. If it becomes 4, I figure out, well, look, the smallest card should be the next card. So I just say, okay, where is my present smallest card? I see index of that, and then index back into this list cards. So, a little bit complicated, but it's kind of like logical. So I find out where I am in the cards list. I just extend that by, I just go to the next item here, and that goes into my smallest card. So in short, my discard pile is 0 to start with, length of discard pile. When the length of discard piles becomes 4, smallest card will become 3. When the length becomes 8, smallest card will become 4, and so on. Now all of this will become more clear when we implement this in code. So like I said, I have changed the game again to become basically, in the determine winner, I again look at the number, not the suit, because the way the game is set up is that way. Now, first thing I'm going to do is to sort of, set up this function. So I just say, well, let's just do it before the loop over here. I say, look, I'm going to say create a new variable called smallest card. And I set it to cards 0 to start with. So that's 2 to start with. I'm going to create a new list called discard pile, and this is an empty list because in the beginning it's all empty. And I define a function here called def, let's say clean up, and I pass to this an argument, say smallest card, because remember smallest card will keep getting updated as the game goes. So I say, well, I'm sending you this argument smallest card. I'm going to look through every card in the table cards list. So I say, well, for say C in table cards, if C1 is equal to say smallest card, if these two are equal, then I know I'm going to have to remove this from the table card. So I'll just say remove from table cards because I need to kind of take it out from the game. So I say, well, table cards dot say remove. See, now again, we are removing by value, and this is quite powerful over here. Of course, once I remove this, I must append this to the discard pile because later on I'm going to see how long my discard pile is to determine if the smallest card has to be moved up. So I just say, well, discard pile dot append C. Now this function is ready. I will call this, like I said, just before the player, let's say, extends the table, extends its pile with the table card. So I just go and say over here, well, clean up. Let's say I say clean up, say smallest card, and maybe just for my benefit, I'll go and print. Let's say over here, I'll just go and print. Let's say, the table. Okay, sorry, my bad here. Say table cards and say discard pile so that we know what's going on. Now I'm going to do the same thing for the computer. So now there's an input statement here. Let it be. I'm going to say, well, clean up and please print for me the the table card and the discard pile. But remember, the cards, the smallest card must be updated, and this part of the code, like I said, could be a little bit confusing, but the idea is very clear. I'm saying that if length of say discard pile, divide by 4, basically, the length becomes a multiple of 4, is equal to the index of the present smallest card plus 1, because remember indexing starts at 0. So I just say, well, cards dot index say smallest card, and I must add this to this plus 1. Now think about this very carefully. Smallest card to start with is 2, cards dot index 2 is 0. So I'm saying that, look, when my discard pile becomes length 4, then I will basically update my smallest card. And the way I will do that is, well, smallest card will now be the next item on the list called cards. So I will just, a little complicated but logical. So I'm going to say, well, this card, the smallest card, sorry, will be exactly this number, because I'll find out where my present smallest card is. I'll add 1 to that and I'll use that cards as the smallest card. I need the same exact code for the computer side, and with this we should be done. We'll test this code. So I come in here just before, let's say, the else gets over, I put this code over here. Now really, this is all we need. We do not need to put this code in the war section, because remember, in the war section we are only putting the cards down, we are not taking them back into the game. Let's see how this works. So now when I play this game, notice, I'll wait for 2 to come by. Totally there are 54 cards, because remember 2 jokers have been added. But wait till we get a 2. Everything keeps looking normal. Now notice here I've got H2 and C3. Computer has 1 because it's C3 and H2. But now this 2 will be moved into the discard pile. We can see this happen. Notice the discard pile is now H2, which means that only C3 went back to play. And we can see that we had 54 cards to start with, but now we are left with only 53 cards. In fact, if we keep doing this, so okay, now again I got a 2. When I see this, because there was a war, so I had a lot of cards in the pair cards, but table cards, but C2 was now moved to discard pile. I am left with only 52 cards, and that's how the cards will keep going down. Let's play this a bit further. Okay, so again I got a 2 that has been moved to my discard pile. All right, so again notice all the 2s have been moved to the discard pile. Now my smallest card is 3. I'm left with only 50 cards in the game. Let's see. So I get 6, 5. I got a 3 now. Notice now my 3 has been moved into the discard pile as well. So this is how the game goes. The number of cards keeps reducing and only the higher value cards remain. Quite interesting. The logic is beautiful and very interesting to look at this. Think about this. Again, I got a 3. I will end up removing this from the game. So notice all these cards have been removed. In fact, very soon we'll be removing 4 as well. So let's just play until there if we can. So I played for a little longer. Notice all the 4s. Well, in fact, all the 3s and all the 4s have also been removed. And this is really cool. because we had a lot of wars. So, a lot of cards got removed in the process. Notice now we are left with only 42 cards in this game, where we had started with 54. And that's how the game goes. Quite interesting. We can play this till the end and see what happens. Notice this 5 has now been removed, h5 and c5, because they must have been played here. This h5 was removed, this c5 has been removed, and so on. So really quite interesting, left with only 40 cards. We still have one more 5. This d5 will get removed, and we will see that, in fact, player is a winner because computer has very few cards left. But notice here, 37 plus 2, 39 cards only, because everything else has moved into the discard pile. Very interesting if you think about it. I hope you found this interesting. In general, if you think this way of learning works for you, look at our website, because that is how we learn Python programming, through fun activities, building them, enhancing them, and understanding concepts through them. Take care. Thank you so much. Bye-bye.